Okay, let's do problem 138, copy list with random pointer. So in this question, we need to construct a deep copy of the list. So deep copy basically means none of the pointers in the new list should point to the nodes in the original list. So basically, if we do, that's what we have, and we want to create a copy of it, but there shouldn't be pointing to the original one. So what do they mean by pointing? So if we do, say, we have head is equal to 7, or head value is 7. So if we do node new head is equal to head, we are essentially creating 7 that's pointing to the head. We don't want to do that. We want to do node new head is equal to new node of value of the value of the head. So in this way, we are creating 7 and then there is no pointer. So this is what we want to avoid and this is what we want to do. So we just need to create a new object by using new operation. And this one is nothing but a singly linked list with additional pointer. So we usually have this int val and node next, but we have additional pointer node random. So if you look at 7 is pointing to 13, which is pointing to 11, and so on. This is just a normal singly linked list, but they do have additional pointer, which is literally pointing to random node. So what we need to do is we're going to go through. We're going to have a loop, and then go through each of the node, and then create a copy of that node using this new operation. So typically we do need while loop, and then we create a copy. So the question is, why are we not assigning the pointer at the same time? Well, say we got up to this 11 here, so we have 7 and then 13 and 11. If you look at this random, it's pointing to something that we haven't created or we can't even create in the next iteration. So that's why we can't establish pointer here. So we do need to have another while loop that establishes pointer for our newly created nodes. So the question is that so in the first loop we created all the nodes, and they would look like this. In the next iteration, we are again going to go through each of the original node, and then based on its pointers, we have to apply the pointers to the new node. But how can the original node refer to the new node? It's fairly simple. It's one-to-one relationship. So we need to create an hash map. So on the right side, we have original node, and then on the right side, we have a new node. So we have 7 here, and then there's a 7 here, this is new. I just wrote down n for new. And then we'd have 13, and then we'd have 13 new. Well, it doesn't look like 13, but so we can use hash map to refer to newly created nodes and then assign pointers. So that's the basic logic. So let's do some coding. So we are given head. So let's work on the most basic edge cases. So if head equals null, we return null. And then we need to create a map of node and then node. Let's just call it map equals new hash map. And then we need to have a first while loop that creates a copy of the node. And then we can actually we can put them into hash map at the same time. So we do need node current is equal to head, and then while current is not equal to null, we keep creating a new node, and then we can at the same time put them into hash map. So we can do map.put, we put the original one, and then we create a new node, and then assign the value, and then we move the current one to the next one. So after this while loop, we would have created all of them and then populated our hash map. And in the next one, we bring current back to head, and then do the same while loop. And then now we are looking at this, we need to get this. And then assign the pointer, so map.get current.next is equal to, and then map.get current.random equals something, and then we would increment current equals current.next. So what goes in here? So if we do say current.next, what we're essentially doing is we created all the new nodes, and we are so it's because 7 is pointing to 13, we are essentially pointing to our original linked list, which we shouldn't do. So what we can do is we can do map.get current.next. So we are getting the current's next one's value, which is the new node that's created and assigned to it. And then do the same thing. We do map.get current.random. So again, 7 is pointing to null, so we are not really directly referring to it. We are getting the key, and we're using the key and then pointing to the newly created node. So after this, we would have created a complete deep copy of it. And what do we need to do? We need to return node, return head of the copied linked list. So basically do return, we can get map.get head. So this would, where head is 7, so it would give us the new 7. Let's run the test. Okay, let's submit. Okay, that's it.